Okay, I think we can proceed to the next part, which is measures of association. And measures of association compare disease occurrences between groups. So ratio measures have a null value of 1, and the difference measures have a null value of 0. So the first measure of association that you're going to look at is what we call a relative risk. So when you talk about relative risk, it's basically risk in the exposed group and risk in the unexposed group. So this is the 2x2 table you're talking about. So this is something you need to really remember, where we have the exposed and the unexposed. And the ones with the disease or no disease could be smoking, no smoking, could be cancer, no cancer. So it varies. I want you just to master how this is. So A, B, C, D. You start with the columns A, B, C, D. So the first column, the second, then A, B, C, D. Then the total for this one. Then also the total, we're having A plus C. So that is the row total, if you want to. A plus C, B plus D. So in this case, you need to remember, for example, if the disease for the exposed is this one, no disease, exposed and no disease this one, unexposed and have the disease this one, unexposed with no disease is this one. So you need to remember A, B, C, D. That's something you need to remember. So for instance, we are having a question here that needs us to calculate the relative risk. In this case, we are looking at risk in the exposed group over the risk in the unexposed groups. So what do we do? Look at the question. Among 500 workers, 100 develop chronic bronchitis or bronchitis. Among 500 non-smokers, 25 developed bronchitis. So the first thing is to develop this table. So how do you develop a table? Let me just show you simple. Because I don't want to finish up this page. So how to develop this table? We're going to have exposed, okay, let me just draw this. This is smokers. Then this is non-smokers. So remember, how to come up with this table is quite important because it simplifies your work. So we are having this is unexposed. Okay. So among 500 workers, 100 develop chronic bronchitis. So 100 develop. So this is so 100 develop. So this is 100 smokers who are exposed. Then among 500 non-smokers, 25 develop. So 25. Then remember, the total is supposed to be 500. The total is supposed to be 500. So what's remaining here for non-smokers? Okay, this is supposed to be 25, yeah, for non-smokers. Let me start. So we are having the smokers and non-smokers. So sorry, let me start. Let me just start afresh on a different slate. In this case, we are talking about exposed, unexposed. So in this case, we are having smokers. Then you're having non-smokers. Okay. Then you're going to have the total. So I have among 500 workers, 100 develop a chronic bronchitis. So 100 of them. Okay. Among 500 non-smokers, 25 developed. 25, these are the ones that are exposed. 25 only, not 250, sorry. So in this case, for the exposed, we're going to have 125. So this is supposed to be 100 out of 1,000 is supposed to be something to, out of 500, 400, then supposed to be 475. Still 500, 500. This is supposed to be 875. So these are the totals, column total, row total. Yeah, so this is basically how it is. So the question that we are having here is, so this is basically what I need to do, the first thing that I need to develop. Once you develop this, then you are at a good place. Just a moment. Okay. So we are having just a moment. Yeah. So the first thing you need to develop is this. Then once you develop that, is when you can now answer such questions. So risk in the exposed group over the risk in the unexposed group. So let's start with the risk in the exposed. So this is our reference point. This is our reference point. So risk in the exposed group is basically going to be, so the exposed group is going to be, let me just do it here. Risk in exposed group. So this basically among smokers is going to be 100. This is 100 over 500. Over 500, which is going to be what? That's going to be 0.2, yeah. So 0.2, if you divide that. This goes there, then 10 divided by 0.2 actually. Yeah. Then risk among the unexposed group or non-smokers. So in this case, we are going to have, I hope that is clear, risk in unexposed group. So in this case, this is non-smoker. So it's going to be 25 over 500, which is essentially this goes here, 25 goes here, 120 goes here. So 0.05. 0.05. Yeah. So to find the relative risk, I don't know if this is clear. The relative risk is essentially the risk in the exposed group, which is this, over the unexposed group. So we're going to have 0.2 over 0.05. So this one you can use your calculator to make work easier. So in that case, you're going to have 0.2 divided by 0.05. So that's 4. So essentially, smokers had 4 times the risk of chronic bronchitis compared to the non-smokers. Smokers had 4 times the risk of chronic compared to non-smokers. I don't know whether that one makes sense. Yeah, if it does, we move to the next one. So how do you interpret this one? So we interpret on a scale of 1. If it's equal to 1, it means no association, because remember we were looking at what? Measures of association. So it has no association. Suggest an increased if it's greater than 1. In this case, an increase 4 times. If it's less than 1, it's more of a protective association. So you need to be very careful on how to interpret. So in most cases, you need to understand how to interpret. If it's equal to 1, no association. Suggest increase, suggest a protective association. You need to remember that. So the next part is the risk difference. So for the risk difference, remember how we have calculated the risk in the exposed group versus the risk in the unexposed group, or the non-smokers. So this is for the smokers and this is for the non-smokers. So the risk in the risk difference, or the attribute risk, sometimes it's referred to as the attribute risk. So you need to remember such kind of terminologies. So when you talk about the risk difference, is basically the risk in the exposed versus the risk in the unexposed, which is quite easy. So we're going to have, in this case, you're going to have just the difference between 0.05 and 0.02. So exposed, which is we calculated, we got it 0.2 minus unexposed 0.05. Yeah, so from the other side. So I'm just taking them from here. 5. So if you look at that, the risk difference is equal to 0.2 minus 0.05. You're getting 0.15. So there were 15 additional cases per 100 or per 1,000, per 100 exposed persons that were associated with the smoking, assuming that the association is like just casual. So you can talk about, if you multiply by 100%, you get 15. So there were additional 15 cases per 100 exposed individuals that were associated with smoking. Okay, the next part is, I have an assignment here that I'll need you to try, but I'm going to give you an hint. So among 400 exposed workers, 80 developed respiratory disease. Then among 600 unexposed workers, 30 develop respiratory disease. Construct a 2x2 table. So I'll just help you do that faster, then the rest you'll do by yourself. So we are having expose, unexposed. So this is add respiratory disease. So develop respiratory. So develop respiratory disease. So DRD, then no respiratory disease, RD. So I'm just abbreviating them. So we are having among 400 exposed workers, 80 develop, so 80 there. Among 600 unexposed, so unexposed, 30 developed respiratory, so 30. So 30. Okay, it's supposed to be 30. 30 develop this. So it's 80. Then we are having, let me just go back a little bit. Among 400 exposed workers, 80 developed, so they had. So the one that didn't have is 300, and 80 minus 400 is 320. 320, the total is 400, yeah. Then among 600 unexposed workers, unexposed, 30 developed respiratory. So 30 had developed respiratory disease, which is 30 here. So the difference is 570. Total is 600. So the first thing is develop this table. I want you to reason out. I'm not going to do it here. Then look at the incident among the exposed, incident among the unexposed. So for incident among the exposed, question 1 is supposed just to be 80 over 400. Then question 2 is supposed to be 30 over 600. Then the relative risk is going to be 80 over 400 over the total 30 over 600. Then odds ratio you're going to calculate is essentially the ratio of it's basically comparing the exposure among people with the disease and the odds of exposure among people without the disease. So in this case, we're going to have odds ratio becoming from this table. This is A, B, C, D. So we're going to have A times D over C times B. So this is what gives us the odds ratio, or R. It compares the exposure among people with the disease to that of people without the disease. So people with a disease among people without a disease. So it's that simple. It's just a cross multiplication of that. Simple. So let's look at what is odds ratio. And that's the next part. It compares the odds of exposure among people with the disease to that of odds of exposure among people without the disease. So from that 4x4 table that we've been looking at, you remember this, it's a simple A, B, C, D. So cross multiplication. So in this case, people with the respiratory disease, people with no respiratory among unexposed, people with the respiratory disease, and people without the respiratory disease. So it's that simple. So in this case, let's look at this question. A case control study calculates 120 lung cancer cases. Among the cases, 90 had smoked and 30 had not smoked. Among the control, 45 had smoked and 75 had not. So in this case, the first thing is look at this table. This table is what guides how you're going to do. So this is the exposed, then the unexposed. So unexposed and exposed. This is it. This is how we're going to get it right. So once you come up with this table, that's the table. Then we are having, in this case, we're going to have the cases, the ones that are, we are having cases, then the control. So we are told among the cases, 90 had smoked. So 90 had smoked. And 35 had not smoked. So This is 30 had not smoked among the exposed. We're going among the control. 40 had smoked, so smoking 40. And 75 had not smoked. So these are the unexposed, 75. So this is the table that you're supposed to have. Once you have this table, just cross multiply. Remember, it's as simple as just doing a cross multiplication. So for cross multiplication, this is A, B, C, D. So odds ratio, OR, is essentially A times D over C times, or B times, either way, B times C. So in this case, we're going to have 90 times 75 over 40 times what? 30. So that's what you need to do. So in this case, let me take my calculator. So for my calculator, we are going to have 90 times 75. That gives us 6,900 over 40 times 30. That's 1,200. So if you divide, if we divide 69 divided by 120, we're going to get 5 point. So this is supposed to be 40. This is supposed to be 45. Sorry. So it's supposed to be 45. So sorry about that. 45 times and 20 times 30 times 30. This gives us 1,350. Yeah, 1,350. So 6,900 divided by 1,350. You get 6,000. Okay, let me just do the maths a little bit. Times 75. Times 75, yeah. So it's 6,750 divided by 1,350. Sorry, so you get a 5. So the odds of previous smoking among people with lung cancer were 5 times the odds of people without lung cancer. So that's basically how you're supposed to do that. Okay, good. So the next is prevalence ratio. So the prevalence ratio essentially tries to understand association that compares the prevalence of health condition in exposed group with those in the unexposed group. So prevalence in the exposed over the prevalence in the unexposed. So the question here we are having I hope this is clear. Prevalence ratio, that's what we're looking at. It measures association that compares the prevalence in the health condition in an exposed group with those prevalence in an exposed group. So the prevalence ratio is essentially the prevalence in exposed over the prevalence in exposed. So in this case, you're having in a cross-sectional survey, 30% of the night shift workers and 15% of the day shift workers report insomnia. So what is the prevalence ratio? So prevalence is going to be 30% divided by this is the exposed group in the unexposed, so the daytime shift 15%. So it's like that is like 30 over 100 divided by 15 over 100. So if you multiply, it's going to be 100 over 30 times that's going to be 100 over 15. If is that right? It's going to be it's supposed to be 30 over 100 times 100 over 15. So this is going to be here, that 100 goes with 100, so this one goes here twice, so the value is 2. So insomnia prevalence, what we can tell about, was twice high among the night shift workers as compared to the daytime workers. So that's it. Yeah, I'll proceed to the next part because this is just a little bit of explanation, then we do just one example and we're almost done. So screening and screening tests and diagnostic measures. So screening tries to identify people who may have a disease before diagnosis is confirmed. So just taking us back to the 2x2 table, there are 4 possible results. So we are having test positive, the disease is present, that is what we call a true positive. But if the disease is not present, it's absent, we call it false positive, because the test gives us a positive that the disease, and there actually there is no disease. The next one is the test is negative, but the disease is present, and that's what we call a false negative. When you do a test that gives you don't have, let's say, tuberculosis, but actually the disease is present, that is a false negative. And the vice versa is where you test negative, but the disease is actually absent. It's true that you don't have that, and the test actually confirms that. It's what you call the true negative. So there's something called sensitivity. So sensitivity answers among people who truly have the disease, what proportion test positive of that? So among the people who truly have that, what proportion test positive? Because sometimes there might be truly the disease, but a small proportion will test negative. So in that case, we're going to look at the true positive over the sum of true positive and the false negative. So we're going to add this plus this. Let me check in an example here. Let's calculate it. Look at this. Let's look at this example here. A screening program test 1,000. Example here. A screening program test 1,000 people. The reference stand that 100 truly have the disease. So when you're coming up with that table, the first thing is you're going to have positive, true positive, the test positive, then we are going to have test negative. Then from here we're going to have disease present, disease absent. So if we're going to talk about 100 truly have the disease, that is the true positive. And have the disease, and 900 do not have. The screening test is positive in 90 diseased people. 90. And in 180 non-diseased people. So in 180 non-diseased people. So in this case, we are having in 180 non-diseased people. So 180 is false positive. So that's here, 180. So now let's calculate. We are having 90 true positive, which is here. 10 false negative. False negative is here. Then we are having 180 true positive there. Then we are having 720 true negative. So the true negatives is supposed to be here. True negative is supposed to be 720. So if you're told to calculate the sensitivity, we're talking about sensitivity being true positive over the sum of true positive plus false positive. So this part. So true positive in this case we are having 90 over 90 plus the false negative, and our false negative is this one, 10. So it's going to be 90 over 100, which is going to be 0.9. So I'll need you to do this one. You can multiply by 100 the specificity once we have gone through them. So sensitivity is what I've explained as it among the people who truly have the disease, what proportion test positive actually, and that's what's called sensitivity. Then we have specificity. So for specificity is among people who truly do not have the disease, what proportion test negative? The ones who didn't have, they truly don't have it, but what proportion test negative? There's some proportion that might be positive, but the ones that are testing negative is what we are interested in. So in this case, specificity is basically true negative over true negative plus the false positive. So these are the sides. So it's that simple. So what you do, once you come up with this table like I have come up with it here, just a simple one. So this is the true negative over true negative plus false positive, and that's it. So in this case, we're going to have true negative is 720. People who truly do not have the disease, what proportion tests negative in that case? So in this case, that one over the ones that are negative. So we're going to have 720 plus false positive 180. So it's going to be 720 over, that's going to be 900. Yeah. So you just need to, but then multiply by 100. Yeah, that value. Good. The next part is predictive values. So for predictive values, we can have positive predictive value, which is the probability that the person who tests positive actually has that disease. And in that case, we are having it as true positive plus the false positive. Then true negative predictive values is the probability that a person who tests negative truly does not have that. The same criteria. In this case, if you're going to use this example, so you're going to have, if you're going to use this example, we're going to have the true positive predictive value is going to be true positive over true positive plus false positive, which is going to be, in this case, we're going to have our true positive being 90 over 90 plus what? The false positive, and false positive is now 180. Then you find the value. For the negative predictive value, it is the probability that a person who tests negative truly does not have that. The one who tests negative truly does not have that. So how do you do that? It's going to be the true negative over true negative plus false positive. Yeah, false positive. True negative plus false, it's supposed to be false negative. Yeah, this is supposed to be false negative. So true negative in this case is 720 over true 720 plus false negative, and our false negative in this case is 10. So it's going to be 720 over 730, and then you get that. That's basically it. The final part is the descriptive statistics, and this part I'd talked about it initially. We start being variable types. Major group in variables, let me just explain this one as fast as possible. We have these four, but I want to explain it where. So in data types, we have, it can either be numeric, and numeric are either 0 to 9 and a combination of that, or can be string, and string could be what you call strings to categorical. These are texts that cannot be quantified. Text, A to Z. So we have two broad categories. Let me just explain that. So data. Data can either be numeric. Numerics are basically numbers, or categorical. These are texts that have been categorized into groups. Categorical from the word category. So for numeric, you can either have two groups. It can either be discrete, and when I talk about discrete, these are whole numbers. When I talk about how many times you've missed a flight, you can only tell me 1, 2, 3, 4. You cannot tell me 1.2 times. How many chances were missed in the last World Cup final that was played yesterday? 1, 2, 3, 4. You cannot talk about 1.1. But if I ask you about what is your weight becomes continuous. And continuous, they can take decimal places. Kgs, weight, for example, weight. Height, 4.6, such kind of things, 5.8. For categorical, we have two groups again. Categorical can either be nominal, or it can be what? Ordinal. Ordinal is from the word order. For example, if you talk about income, people earning between 10,000 to 0 to 10,000, 10,001 to 20,000, 20,001 to 30,000 US dollars per month. So ordinal means I can rank somebody who is in this group is earning more than this one. You can talk about this, the first group, second group, third group. In terms of ranking, you can rank this kind of information. This is ordinal. But talk about nominal. Nominal is like gender, male and female. There is no universal way of ranking such kind of information. Departments, if you don't attach something to them, you cannot rank. So they can become nominal. So this one, no, you cannot rank them. This one you can rank. There is no standard way of ranking such kind of information. No standard or universal way of ranking. But this one you can rank, you can order them. So that's basically good. The last part is if you want to find measures of central tendency, like mean. So we have like values like 10, 30, 40, 50. So for you to find the mean is basically sum of these ones. So this one plus this one is 40, 80 plus 15 is 130. 130 divided by 1, 2, 3, 4. So you get your value there. The median is if you rank order them from the smallest to the, let's say this is 9, we have a value here 90. So for you to find the median, you order them from the smallest to the largest. 10, 30, 40, 50, 90. So the one at the middle, this, because this cancels this cancels this. The one at the middle, so the median value is 40. The mode is the most frequent, assuming we had a value here 10. So the model value is the most frequent. So if you look at 90, 10, 30, 40, 50, 10. So look at the most frequent value. So this one has a frequency of 1, 1, 1, 1. But this one has a frequency here again. So meaning it has a frequency of what? 2. So this is the most frequent value. So the model value is 10. So those are basically the simplest way to explain that. I don't know whether that makes sense. I'll stop the video there, then proceed later.